We are going to be talking a lot this year about functions, and we want to just go over some basic concepts about functions today. I want to make sure that you can identify the domain and the range of relations and functions and determine whether a relation is a function. And you can just cross off that S right there. It should just be function. All right, let's look at some vocabulary words. A relation is a pairing of input values X with output values Y. So if we're looking at the domain, we're talking about just the input value, or X. If we're talking about the range, we're looking at the output value, what you get after you substitute the domain, or we're talking about the Y. So let's look at an equation. And if you have y equals 2x plus 1, and you say, let's let x equal 3, then that means you're letting the domain be 3. And then you'll get the range by substituting 3 into the equation. So 2 times 3 plus 1 will give us 7. That means our ordered pair, if we're using this equation with a domain of 3, our ordered pair will be 3, 7. A function is a set of ordered pairs, and I didn't have enough room to write that, so I'll just kind of squeeze that in there, in which the first coordinate x is never repeated. Now, each element of the domain is mapped to exactly one element in the range. And you can test that visually by doing something called the vertical line test. And sometimes students get confused which way is vertical and which way is horizontal. So off to the side here, I just drew a vertical line, and then the V is oriented like it would be if you would normally write it. So maybe remember that if you're thinking about vertical and you have a hard time remembering which is vertical and which is horizontal. So a vertical line test, if you draw a vertical line and it passes through more than one point of a graph of a relation, and a relation is, again, is a set of ordered pairs, the relation must have more than one point with the same x value. And since there's more than one x coordinate, in other words, the x's repeat, the relation is not a function. Now you can represent relations by mappings, and a mapping is just a diagram that shows the relationship of the elements in the domain to the elements in the range. And I'll show you that in just a few minutes here. Okay, if you have problems remembering the domain or in the range, which one is which, just put those words in alphabetical order, and then put X and Y in alphabetical order. And if you do that, X will line up with the domain, Y will line up with the range. Okay, there are some things that you need to remember when you're listing the domain and the range. The first thing is you need to order them from least to greatest. Second thing is that you do not list repeats. The third is that you enclose them in braces. And then the fourth is that you separate the elements by using commas. All right, so let's identify the domain and range. We're going to do that from a table, from a set of ordered pairs, and from a graph. Here is a table representing cooking times. So we want to list the domain, which means we're only looking at the x's. Here they're already ordered from least to greatest, and there are no repeats, so that one's pretty easy to do. Same thing with the range. Already ordered from least to greatest, and there are no repeats. Now, if we're identifying from a set of ordered pairs, I'm just going to erase this here real quick. I underlined the x values, and if we look at the x values, we have 54, 57, 54. If we write down 54, it's listed twice, so we only list it in our set one time. And then we have 55 is the next one, and 57. So we have all the elements in the domain. They're listed from left to right, or least to greatest from left to right. And then there are no repeats. The range, we have 3. We have 2 4s, but we only list them one time. And then we have a 7. All right, let's move on to the graph. Looking at a graph. And the ink looks a little light here. It was a colored graph that I inserted, so I wrote the ordered pairs here. And they're all down here for you to see. And what we want to do is we want to list just the x value. So if we read that graph from left to right, we can see that the domain is -2, -1, 0, 1, 2, and 3. And there are no repeats there. If we're listing the range, then we need to start with the lowest value, so we need to start down here, and that would be -3 to -2, -1, 0, 1, and 2. So there is your range. Okay, so how do we determine if a relation or a set of ordered pairs is a function? And the way that you do that, a relation, which means a set of ordered pairs, is a function if the x's do not repeat. Now, the y's can repeat, but the x's can't. So you want to make sure you are looking at the x's when you're deciding if you have a function. So now we are going to not just determine the domain and the range, we are going to decide if those previous examples are functions. So I'm looking at this, and the only thing I'm concerned about, do the x's repeat? The x's do not repeat, so we have a function here. So the answer is yes, the x's do not repeat. Now, when we look at the set of ordered pairs, we are, again, only looking at the x's. It doesn't matter what the y's are, so you can just cross those off. But we're looking at the x's, and here we have 54 repeats. So that is not a function because the x's repeat. Determining if we have a function from a graph, we can use the vertical line test. The vertical line test, again, goes north and south, and anytime it passes through 2 or more points, it's not a function. So this is not a function because we have x, the x's are repeating. So x's repeat. Okay, now we're going to use mapping to represent a relation or a set of ordered pairs. And you have an example here how mappings can be used. They show a relation with x and y. So here we would say we could have, if I would list these as ordered pairs, it would be 2a, 2b, 2c. Here it would be a comma 2, b 2, c 2. So when you're looking at the mapping, I circled the domain. That's all you need to look at. You don't even have to pay any attention to the range. So look at domain only to determine if you have a function. So you can tell if a relation is a function by looking at the number of arrows coming out from each element of the domain. If there's more than one arrow coming off from any member in the domain, the relation is not a function because that means the x's would be repeating. If I would list, again, if I would list this out, I would have a 2a, I would also have a 2b, so the x's would be repeating. Now we're going to be determining if a relation is a function from mapping. Okay, so here, I off to the side have listed what this mapping represents. We have 3, 1, 3, oh no, that's 3, -1, 3, -2, 6, -1, 6, -2. All right, so this cannot be a function because here we have x's repeating, here we have x's repeating. Don't even worry about those y's. So it is not a function because the x's repeat. Our domain would just be 3 and 6, those numbers in the first figure there, and our range would be -2, -1, because we want to list them in order from least to greatest. And usually you should do that also in here. All right, the next one has the domain and range listed sideways, so that's not a big deal. We still can list the items or the elements in that set. And so we can do 3, -1, 3, 0, 5, 0, 7, 9. And then we have repeats here. So that is not a function. And our domain, 3, 5, 7. And our range is -1, 0, 9. All right, now it's your turn to finish up that last page, and then there's a spot down here to write down any questions you would like cleared up in class. And if I don't have these at the bottom of your notes, then just write them either on the back of your notes or wherever. So if you don't feel comfortable asking questions in class, then I can just come around and check your notes and work with you individually.